Uh, at this video we are gonna talk about the graphing rational function, radical function, radical function, uh, rational function, functions, and then logarithmic function, and then exponential. So uh, so let's start first. Radical functions. We turn this on, clear, and then you see y you clear this and you write the function, like for example 1 over x, rational function. First of all, talk about rational function, and then x. See, if you push graph, it's gonna graph this for you. See, it's gonna be it's gonna be something like that. Y is equal 1 over x. See, let's drive. If you wanna get closer to what you should zoom, and then in. See, you see a better idea of what's going on. So let's find another function like 1 divided by x. You use x minus 1, and then graph. It's so easy, to see. The x is equal to minus 1 means x is equal to 1 here. This is x is equal to 1 here, and then at 1 the vertical asymptote x is equal to 1. If you want to zoom it, standard 6. See, at x is equal to 1 we don't get any answer. See, you mean it's gonna get to rational function. Y is equal 1 x minus 1. Okay, what is showing here at x plus 1 is, you said this one 0, x minus 1 is 0, x is equal to 1. This is a vertical asymptote. Means and x is equal to 1 vertical asymptote, and this is going to be like this, and this is going to be like this. So we can't give x 1, because if you give x 1, it's going to be 1 over 0, it's going to be infinity, you know, or undefined. So it's so easy to graph this, you know, these are, you don't have to give value to x and find y. And let's talk about another one, y. This time we say, let's clear this one, 2x divided by let's say this is 2x minus 1. You use parentheses, you better use parentheses. You add a parenthesis here and then divide it by x x plus 1 or whatever, you know, it's x plus 1. And then you graph, you just show this one and it graph it for you. See what it's saying, that x is equal to graph, second quit, and then, you know, you see the graph here, 2x minus 1. We will talk about it in details maybe later, because this is where intercept x-axis, you know, the numerator, where intercept somewhere x-axis, and that is that's why then if you set the numerator to 0, equal to 0, you're going to find the where intercepted. So if you bring closer here, zoom in, enter, see it intercepts. This one is to see what is the interception. Let's see to see what is the interception for x-axis. What we do use second, calculate 0, and then we say that the left bound of this 0 is this one, and then move it to other side 0, and then again enter. It is equal to 0.5. See what it means, that 2x minus 1, if we set 2x minus 1, the numerator is equal to 0, x is equal to 1 over 2, where intercept y-axis. And then we have in the numerator x plus 1. X plus 1, you know, we have this one here, x, the denominator x plus 1. X plus 1 means x plus 1 is not going to be 0, it's going to be anything else. That it is going to be x, it's going to be not 0, any number. If I'm sorry, this is going to go there. You can put at this equation 2x minus 1 and then x plus 1. See here, minus 1, you can have no x minus 1. So the if you put -1 here, you know, let's see. So see, we see the whole. See, at x minus 1 is going to go to infinity. We can't have x at if x is -1 plus 1 is going to be 0, and then 1 divided by 0 is infinity. It's just undefined. So x can't be -1. So let's go to other functions, like you say here clear, and then second, for example, x. Let's draw this one. See what it shows here, that y is equal x. It's got, you give value to x, and then you know what you did is see x value here and the y value, and then you give x something that when you square root of that is going to be an integer, like 1 is going to be 1, 4 is going to be 2, and so on. So it started from 0. It's going to go over there. It's 1 1, and then 4, 1 2 3 4. This is 1 2 3 4. Okay. At 4 is going to be 2. So we draw this one. You know, how about if x is equal to y? We get y, but this one is going to be x plus 2, and then we graph this. See, 2 units came the other way. So the equation was y is equal we are talking about the graphing radical function x plus 2, right? We use that x plus 2. So if the under radical, this x plus 2 is got to be greater or equal to 0. So when we solve this one, x is equal greater than -2. And what it here means is 1 minus 2 started from here and then go this way. So -2. So it got to be greater or equal to -2 in order this going to be valid. You know, we graph this equation. We cannot give -3 because -3 is going to be -1. If we give x -3 plus 2, it's going to be -1. This is an imaginary number that we will talk about. We don't use it very much. That's imaginary number. Like if you had minus 49, the square root of that, we say minus, we can write like this, square root of -1 times the square root of 49. And then 49 is going to be 7, and the square root of -1 is 7i. You got it. So we will talk about it later. About it. So this got to be larger. All the value that x you can give to x, you know, it's going to be 7. It's going to be 7 here. Here, 7 plus 2 is going to be 9. It's going to be 1, 2, 3. It's going to be 7. X is 7 plus 2 is going to be 9. The square root of 9 is going to be 3. So 3 here. So we find this point here. So the domain of this one is going to be the value of x. The domain of this one is going to be -2 included -2 up to plus infinity. Up to plus infinity, you know. and the y value, the range we talked about it earlier, is going to start from -2. It's include -2 up to, I'm sorry, 0. 0, it starts from 0 here. 0 up to include, 0 up to plus infinity. So we don't want to talk about this right now, but we just want to graph these functions. So we, how about this one is we get out of radical plus 3. What's going to be show? It's interesting to see that this is going to start from the 2 and then plus 3. We said this one. This is going to be a start from x minus 2, x plus 2 is equal to 0, x is equal to minus 2, x minus 2y plus 3. See, minus 2 here and plus 3. They start from here and then go there. So if you want to find the value for x minus 2 up to infinity and plus 3 up to infinity for the domain and range of these functions. So let's talk about exponential function. 2 to the power of x is going to, to the power of x. See, graph it. See, it's going to be like this. And then we add some thing here. Y gonna say x plus 2. See? See, actually what happened that, see, x 2 to the power x plus 2. And sometimes, okay, let's write another one, a 2 to the power of x minus 2. See, two units. 2 units this way, and then you see that it shifts this way. Okay. So let's how about if x plus 3. Let's deactivate this one, the second one. We push enter again, and it's going to be just equal. Not the top one is highlighted. So actually, what happened at y is equal to 3? This is going to be the vertical, the horizontal asymptote. See, 3 is going to be move this one up 3 units, and if you want to show this one also, see, you see the difference. This is vertical, horizontal asymptote is up x-axis, and is on the top of the x-axis, but here has 3 units up there. So this is about graphing this, and then we get to the logarithm function. Graph this. We clear and then clear. See, you could find sometimes the intersect by x-axis. You can find 0 for that, or you have two curves that you want to see the intersect of that. See, now we are gonna draw this one. See what you do, we say y, and then we go to math, and then we go to here. We are gonna log. It asks you for the base. So in some, if you want to write it, let me bring you if, for example, log base 4, and then that one x. See how it look like. See, if you want to magnify that, see, this is log of x with the base 4. You know, it's gonna be so it's gonna be something like this. Intersect the 2 to the power of, you know, like say y, this is y is equal to, this is y, like is 4 to the power of x. This is going to intersect, if x is 0, this is going to intersect at 1. If x is 0, 4 to the power of 0 is going to be 1. So at this, but this one, it's going to intersect the x-axis. That was intersecting y-axis. This is intersecting x-axis. And so and then if you want to find the 0 of that, find the 0, you say second, calculate 0, enter. I said, where's the left bound? The left bound of this 0 is here, and then we go to the right, and enter, and then enter again. It say x is equal to 1. X is equal to 1 here. X is equal to 1. See, it just, that's why they say they are inverse of each other. They. So let's see another. If this one is x minus 3, okay, and then see what it look like. See, we say zoom 6. See, it started from here. At x is equal to 3, is going to be a vertical asymptote. X is equal 1, 2, 3. This is going to be it's going to be like this. Okay. if you see, you know, because x is equal to 3. So this one was x minus 3, right? The equation, it was the function, yeah, it minus 3. So the vertical asymptote is this. And for this one, we had a horizontal asymptote. Horizontal asymptote is like here is if it was plus 2, it started from here, and it's going to be like this. So we go 2 units up there. So let's get this one to find another to see. So what happened is plus 1. Graph it. See, it's moving this way. Wait, x plus 3. X plus 3 is equal to 0. X is equal to minus 3. So it's going to be shifted 3 units to the left. And how about we add another plus 4 example, and then graph it. See what's going to happen. This is going to get at x. It's going to be here, this one here. It's going to be minus 3. X is equal to minus 3. It's going to be like that. So it doesn't show the rest of that. It shifted up there 4 units, and so if x minus 3 was going that way, if it's minus 3, then graph it. See, it's shifted this way. Minus 3 x minus 3 is equal to 0, and x is 2. And the vertical asymptote for this one is x is equal to 3. This is the y is equal to log of 4x minus 3. This is x plus 3. Log of x plus 3 base 4. So that's the way you draw this by calculator, and you see that it's very easy. It's very easy to graph this with calculator. We already showed how to do it by hands, and so you got to practice yourself in order to learn more. To you got to code and encoding and decoding. Somehow you code this material in your brain, and then when you want to solve the problem, you use that decoding those things that you learned, and you can